Hello, my dear students. I once again welcome you all to this current lecture. In the last lecture, we studied one important point from the chapter that is called as the hybridization phenomena. What is meant by hybridization, how it can be defined, and what are the different types of the hybridization, how the methane molecule is formed by sp3 hybridization. So that important points we studied in a last lecture. Now in a current lecture we are going to start the next important point from the chapter that is called as aromaticity, Benzenoide and Huckel's rule. So this is one important point from this chapter. So as far as the organic compounds or molecules are considered, these organic compounds or molecules are broadly classified into two types. The first type is called as the aliphatic compounds and the second type is called as the aromatic compounds. We know very well that aliphatic compounds are nothing but that are straight chain compounds or branch chain compounds in which the cyclic structure is absent, while in these particular aromatic compounds what happens, these compounds are cyclic compounds. So this is the two fundamental types of the organic compounds. So we are interested to study this second type of the compound, that is the aromatic compounds. What is meant by these aromatic compounds? What is the importance of these aromatic compounds? That we have to study now. So what happens, these aromatic compounds? So in an ancient day, these aromatic compounds are to be recognized as these are such a type of the organic compounds which have a special type of aroma or a special type of the fragrance similar to that of the benzene molecule. So those compounds which have a special type of aroma or fragrance similar to that of the benzene molecule, they shows a similar chemical and physical properties. Similar chemical and physical properties So that compounds we can see here, that is aromatic. So in ancient time, this is a common method of the word aromatic, means it is a compounds which have a special type of aroma or fragrance similar to that of the benzene. Now what happens, if we want to assign the nature of a given organic compound as aromatic or non-aromatic, what happens, we have to take into consideration some important rules. So some important rules are given by the scientist Huckel. So that is called as the Huckel's rule of aromaticity. In order to assign the aromatic nature of organic molecules, the important rule is there, that is Huckel's rule of aromaticity. Huckel's rule of aromaticity. How a given compound is called as aromatic or non-aromatic. So for this purpose we have to take into consideration this Huckel's rule of aromaticity. Now what happens, according to this Huckel's, some requirements or some rules are given for aromatic compounds. So among that, the first important rule is for the given organic molecule, that is the compound must be cyclic in nature. This is the first requirement by this Huckel's rule. The second important rule is it must be planar. It must be planar in nature. It must be planar in nature. The third important rule is it must have alternate single and double bonds. it must have alternate single and double bonds. This is the third important rule given by this Huckel's. And next important rule number 4, that is each carbon must be either sp2 or sp hybridized. Each carbon must be either sp2 or sp hybridized. This is the fourth important rule. And the last important rule is rule number 5. It must have 4n plus 2. It must have 4n plus 2 pi electrons in its structure. It must have 4n plus 2 pi electrons in its structure, where this n is a integer, having the possible values of 0, 1, 2, etc. So these are the possible values for this n. So we can say here that the Huckel's rule for aromaticity is very important as far as the assigning the nature of a molecule is considered. So we can say here, if a given organic molecule is there, it must obey all these rules given by the Huckel's. If it obey all the rules, then we can say here the given organic molecule is aromatic in nature. Now we have to look towards what is the meaning of each and every rule. So the first important rule given by Huckel's is the compound which we taken here must be cyclic in nature. So if a compound is a cyclic, then and then only it may be aromatic in nature. It is not a confirm, but we can say here it may be aromatic in nature. If we look towards the second important rule, according to that rule, it must be planar in nature. So what is the meaning of this? All the constituent atoms of this particular molecule must be present within a single plane. So we can say here that molecule must be planar in nature. The third important rule is that that particular planar cyclic molecule must have alternate single and double bonds. The single and double bonds must be alternate in a given molecule, or we can say that there must be conjugation. There must be conjugation in a given cyclic molecule for aromaticity. The fourth important rule is that each carbon present in a given cyclic compound must be either sp2 or sp hybridized. Its hybridization must be sp2 or sp, but not the sp3. So this is the fourth important rule given by the Huckel's. And the last important condition is that the compound must have 4n plus 2 pi electrons in its structure, where n is an integer having a possible values of 0, 1, 2, etc. So these are the important rules given by the Huckel's. So these rules are called as Huckel's rule for aromaticity. So these rules we have to apply now for some important organic compounds. So for this purpose we take here first known example of aromatic compounds as a benzene. We know already that this benzene is a aromatic compound, but why it is aromatic, so that we have to verify with the help of these particular rules given by the Huckel's. So the first important rule, that the compound must be cyclic in nature. So it obey that particular rule. It is a cyclic in nature. The 6 carbon atoms are arranged in a cyclic manner with a particular single and double bonds. The second rule is that it must be planar in nature. So this benzene molecule is a planar in nature. All the constituent atoms, that is carbons and hydrogens, are present in a single plane. So it is a planar in nature. The third important rule is it must have alternate single and double bonds. So if we look towards the structure of this benzene molecule, the single and double bonds are alternate in nature. There is a conjugation is present, so it also obeys the rule number 3. The fourth number rule is each carbon must be either sp2 or sp hybridized. So if we look towards the hybridization of every carbon atom, hybridization of every carbon atom in a benzene is sp2 hybridize. It is the sp2 hybridize, so it also obey rule number 4. Now if we apply the rule number 5, that it must have 4n plus 2 pi electron in its structure. So if we apply these rules, 4n plus 2 pi electrons, so if we apply these rules, if we substitute the value for this n is equal to 1, and if we solve it, the answer comes out to be 6 pi electrons. So according to this rule number 5, it must have 4n plus 2 pi electron, that is a 6 pi electron. If we look toward this benzene molecule, it have the 3 pi bonds. It have the 3 pi bonds, means how many electrons? 6 pi electrons. So both these electrons are in a good agreement with each other. So we can say here, as the benzene molecule obeys all the rules or all the conditions given by the Huckel's rule of aromaticity, and that's why this benzene molecule is called as the aromatic. It is called as aromatic in nature. So benzene is aromatic as it obeys all the rules, all the conditions of this aromaticity. Secondly, if we take the next example for our discussion, if I take here a molecule which have one heteroatom, if I take here the molecule like this, one ring is there which have one heteroatom, and this atom is called as the pyridine. This is a pyridine molecule is there which is a heterocyclic compounds. Now if we want to assign what is the nature of this molecule, whether it is a aromatic or non-aromatic, so again we have to apply all the rules given by the Huckel's. That is, it must be cyclic, so it is a cyclic in nature, it is a planar in nature also, it must have alternate single and double bonds. So it also obeys the condition number 3 also, alternate single and double bonds is there. Each carbon in this pyridine molecule is sp2 hybridize. Each carbon is sp2 hybridize. And the next important rule is that it must have 4n plus 2 pi electrons. 4n plus 2 pi electrons. So if we apply this rule, so what happens here? If we substitute again 4 into 1 plus 2 pi electrons, that value again comes out to be 6 pi electrons. And if we look toward the structure of this pyridine, 3 pi bonds is there. 3 pi bonds are there. So how many electrons? 3 pi bonds means 6 pi electrons. So we can see here both these number of electrons are in a good agreement with each other. So this pyridine molecule obeys all the rule for aromaticity, and that's why this pyridine molecule is called as the aromatic in nature. This is aromatic in nature. So this is the second example for this aromaticity phenomena. Now if we take here some another examples for aromatic compounds, so for example if I take here the third example for our discussion, the molecule, this type of the molecule I take here. So if we want to assign the nature of this particular molecule, whether it is aromatic or non-aromatic, so again we have to apply all the rules given by the Huckel's. So in this case what happens, if we apply the rule number first, it is cyclic in nature, so it obeys the rule number first. It must be planar in nature, so it is a planar also, it is a cyclic compound also. The third important rule is that it must have alternate single and double bonds. Now if we look towards the single and double bonds position, what happens, this is a double bond, single bond, again double bond is there, but 3 continuous sigma bond is there. So you can see here no alternate single and double bond is there, or there is a absence of conjugation, no alternate no alternate single and double bonds, or we can see here absence of conjugation, absence of conjugation. And as this conjugation is absent, we can say here this molecule is called as the non-aromatic molecule. It is the non-aromatic molecule. So this molecule must obey all the conditions, then and then only we can say that that molecule is a aromatic in nature. So this is the example number 3. Now if I take some another type of the examples, it is example number 4. If I take here the 4th number example, that is if I take here the naphthalene molecule, if I take here the naphthalene molecule, the two benzene rings are joined together, so it has the 3 double bonds and it has the 2 double bonds. So this is nothing but the naphthalene molecule. Now we are interested to assign the nature of the particular naphthalene molecule, whether this molecule is aromatic or non-aromatic. So again we have to apply all the conditions or rules given by the Huckels. So what happens? This molecule is cyclic in nature. This molecule is cyclic in nature. All the carbon atoms are present in a cyclic manner. So it is cyclic in nature. It is planar also. It is the planar molecule. It is the planar molecule. Next important condition is that there must be alternate single and double bonds. So these single and double bonds are present in an alternate manner. So we can say here alternate single and double bond. Alternate single and double bonds are already present. So it obeys the rule number 3. The 4th important rule is that each carbon in this molecule must be either sp2 or sp hybridized. So we can see here each carbon is a sp2 hybridized. Each carbon has the sp2 hybridization. And the last important rule is that it must have 4n plus 2 pi electrons. So if we apply this rule, last rule, 4n plus 2 pi electrons. So if we take here 4 into value for n is equal to 2, plus if I take here 2 pi electrons, so the value comes out to be 10 pi electrons. The value according to this rule comes out to be 10 pi electrons. If we look towards the structure of this molecule, how many pi bonds is there? 1, 2, 3, 4 and 5. So 5 bonds, 5 pi bonds is there. Each pi bond have the 2 electrons each. So each 5 bonds is equal to nothing but the 10 pi electrons. So we can say here these two values of pi electrons, or these two numbers of pi electrons, get similar to each other, and that's why we can say here this naphthalene molecule is called as the aromatic in nature. This molecule is called as the aromatic in nature. So this is the important example of aromatic compounds in which 2 benzene rings is present. Now if I take the next example for our discussion, if we take here a 5-membered ring having one heteroatom, if I take here the molecule like this, 5-membered ring is there which have one heteroatom, that is a oxygen is present. Suppose this is the oxygen atom. Now it has the 2 pi bonds and 2 lone pairs are present on this particular oxygen atom. So this molecule is nothing but the furan. This is a furan molecule is there. So we have to assign now the nature of this particular molecule, whether it is aromatic or non-aromatic. So again we have to apply all the rules. Now it is a cyclic molecule, no doubt it is a cyclic. It is the planar also. It is a cyclic molecule as well as planar molecule. There is a conjugation of single and double bond must be there. So what happens in this case? This is a double bond, single bond, again double bond, single bond, again single bond is there. But what happens here? these two non-bonding electrons are present which are assigned to this particular conjugation. They are present in a conjugation with this particular double bonds, and that's why we count it in the conjugation. So it has the conjugation also. It has conjugation also. That is alternate single and double bonds. And the last important rule is that, so before that, one important rule is each carbon must be sp2 or sp hybridized. So we can see here each carbon is of sp2 hybridization, and if we apply the last important rule that it must have 4n plus 2 pi electrons. So now we have to apply this last important rule. If I take here 4 into value of n, I take here 1 plus 2 pi electrons. So what happens? This value comes out to be 6 pi electrons. Now we have to look towards how many pi electrons is present in this particular molecule. So it has the 2 pi bonds. It has the 2 pi bonds as well as one non-bonding electron pair. So 2 pi bonds and one non-bonding electron pair. One non-bonding electron pair is present in this molecule. So all these electrons, if we add together, it becomes equal to 6 pi electrons, and our requirement is also 6 pi electrons. So we can say here this molecule obeys the 4m plus 2 pi electrons given by the Huckels. So we can say here this furan molecule is called as the aromatic in nature. It is called as the aromatic in nature. So we take here the 5 different examples for this aromatic compounds. So in this current lecture we started one important point that is called as aromaticity, Benzenoide and Huckel's rule. What is in by aromaticity? So we can see here basically organic compounds can be classified into two types, aliphatic and aromatic. So we are interested to study these aromatic compounds. So in the ancient days, or at the beginning, what happens? These aromatic compounds are to be nothing but compounds which have a special type of aroma or fragrance similar to that of the benzenes. So that particular compounds are called to be as aromatic compounds. But after that, what happens? An important rule was given by the Huckels called as the Huckel's rule of aromaticity. So that compound is considered to be as a aromatic compound which obey the 5 different type of the rules. If the compound obey all these rules, then and then only that compound is considered to be as a aromatic in nature. So we can define an aromatic compound is such a compound which must be cyclic in nature, which must be cyclic, planar in nature, having alternate single and double bond, containing 4n plus 2 pi electrons, then that particular compound is called as the aromatic compound. So for this purpose we take here some different examples of aromatic as well as the non-aromatic compounds. We take here benzene, it is to be aromatic compound. We take here pyridine compound, it comes out to be aromatic in nature. The next compound is a cyclohexadiene, it is a non-aromatic in nature. And the last 2 examples we already discussed here, that is example number 4 is a naphthalene, it is also aromatic in nature. And the last example is of furan, which is also aromatic in nature. So you can see here the aromatic compounds are such a type of the compounds which is cyclic in nature, planar in nature, having alternate single and double bonds. Each carbon is either sp2 or sp hybridized and must have 4n plus 2 pi electrons. Then all such type of the organic compounds are called as the aromatic compounds. So this is an important point from this chapter, aromaticity. So the remaining points from this chapter we will take in a next lecture. With this I stop here. Thank you so much.